In the next video, we're going to use proof by contradiction to do a proof. So let's introduce you to that so you see what's going to go on. So proof by contradiction could be something like this. For example, somebody stole some jewelry and goods from some store or something. And two people are accused because they're the only two people that had motive and opportunity. So one person is Karen, and the other person is Sam. Okay? Now, someone took some bag of jewelry and gold and some other goods that weighed 250 pounds. And so, if these are the only two people that did it, it's one or the other. We could show one didn't do it by saying, you could imagine a lawyer in a court. Okay, so here we have Karen, this petite 115-pound girl, this lady. So, okay, yes, she's in CrossFit. She's strong. She's paleo. She works out, but she didn't even deadlift or squat 225 pounds. So you're asking me to believe that this 115-pound girl picked up a 250-pound bag, carried it up and over a fence, and then carried it 50 yards? That is absurd. You're expecting us to believe something ridiculous and absurd if you're claiming that she committed the crime. Clearly, Sam, who weighs 250 and can squat 400 and carry heavy weights, clearly he must be the one that did it. That is absurd. Okay, so you see what a lawyer or a person could do there is use certain characteristics of Karen, and you show that it would be absurd to believe she committed the crime because of what's going on, whereas he could have done it. And notice in this case, we only have two possibilities. Okay? It's one or the other. That's how proof by contradiction is to work. If there could also be another person who committed the crime, Michael or whoever, Mark, then this wouldn't work. We'd have to do more contradiction or more reasoning to show it's one of these people. So when we're doing some of this stuff, we're going to do simple contradiction proofs where it's one thing or another. This or this. So notice the pattern is like A or B. Or you could think A or not A. Okay, so something could be red or it's not red. It can be some other color. The person who committed the crime or saved someone's life could be Karen or Mark. Okay? So there's to be only two options, nothing else. Here there's always two. Something's A or not A. No other possibility. But notice with colors, something like it's not merely red or yellow in a lot of situations, because it could be red, yellow, blue, green, purple, white, black, whatever. But in certain situations where something can only be two colors, then we could do something like this. Maybe a swan can only be white or black, right? Some animals or some things that we make can only be two colors. Or sometimes one. Like early Fords were black or black. That's the only color they made. Okay, but this is the basic idea. So if we have two things and we show one of them is absurd, then the other one must be true. All right, and that's what we're going to do. So just like if we've got, if we look back in early history of thinking, then an early, maybe one of the first uses, certainly one of the most famous that I'm aware of, is a proof that the square root of 2 is irrational. Now, I'm not going to go into this proof fully. You can look it up, proof that the square root of 2 is irrational, like on Dr. Michael Fowler's website. He's a physicist at the University of Virginia, UVA. Put in his name, put in square root of 2, proof, and you got to find a good write-up of this. But basically, what someone showed is that the square root of 2 is not rational, so it's an irrational number. Now notice we have not a ratio. That's all that irrational means. Not a ratio of numbers. This just makes it an adjective. Irrational is an adjective. We add the AL on at the end to make a noun into an adjective. A noun functions as an adjective. And we put the N there so it sounds good, because ratio would be kind of weird. It's easier to say rational. So a ratio of integers is like 3 to 5, or 4 to 7, or 2, because 2 is like 2 over 1. Okay, so these are rational. They're rational numbers, but irrational means not irrational. So the square root of 2 is not a ratio of integers. And basically what the Greeks did to do that was, it's either rational or irrational. No other option. As we talked about, it's like A or B. A or, in this case, not A. Rational or not rational. Now, if we assume it's rational, then it'd be the ratio of 2 integers. So square root of 2 would be something about maybe around 22 over 7, or some better approximation. But if we assume that square root of 2 is equal to a ratio of integers, then when you work this out, the basic idea is that you see these are both being equal to the square root of 2. It would mean that these are both even numbers. So you'd have like 2m and 2n. But we started with the assumption, which I forgot to say, but we started with the assumption that this was in reduced form. It couldn't be reduced. So if this is a rational number and we get a fraction in lowest terms, then by doing some reasoning you can show that it's not in lowest terms, which contradicts the fact that it was. So there's a contradiction. If this is a rational number and it's in lowest terms, you can do some reasoning which ends up saying that these are not in lowest terms because they're both even. Something would divide out. So that's a contradiction. Like I say, you can look in the proof and see more what's going on. But we contradicted the assumption that it's rational, so that's not true. So therefore, it must be irrational. Okay? So that's the idea. So we're going to be doing something like, you've got a line segment and you have a perpendicular, and we're going to say a point is either on the perpendicular or it's not. And we're going to show that if you assume it's not on the perpendicular, then you're going to get a contradiction. You're going to say it's not on the perpendicular, but you're going to do some reasoning and figure out that it has to be on the perpendicular. So you start out assuming it's not on the perpendicular, but then you conclude that it is on perpendicular, which is a contradiction. It cannot not be on it and be on it at the same time, same place, and same respect. It's a contradiction. So the assumption that you're not on the perpendicular leads to a contradiction. So you must be on the perpendicular. Okay? So that's what we'll do in the next video. Get ready.